In this video, let us see how to find the volume using triple integration. First question is find the volume of the sphere x square plus y square plus z square is equal to a square using triple integration. So already we know that volume is equal to triple integral dz dy dx is the formula to find the volume using triple integration. So here we are going to find out the volume of the sphere. So sphere is given by the equation x square plus y square plus z square is equal to a square, means this is a sphere with the center origin and radius a. So if you notice, this is a sphere, that is three-dimensional diagram of a sphere, that is by considering the center point as the origin O. So origin O means 0 comma, the coordinate points are 0 comma 0 comma 0, right? And then here the radius is a. Equation of the sphere is x square plus y square plus z square is equal to a square, means center is the origin and radius is a. So radius is a, means this is a. This distance is a. Similarly, this distance a, this distance a. That is radius is a. Okay, so here actually you have to imagine that this is to be x-axis, this is to be y-axis, and this is to be z-axis. Like this you have to imagine. So here if you imagine this, so to evaluate this triple integration, we want to identify the limits. Okay, so the lower limit and the upper limit. So since this sphere is symmetric about the three axes, we can consider the one part of that which lies in the first octant or positive octant. Octant is nothing but 8 parts. That is, we can divide the sphere into 8 parts like this. That is, if you imagine the center point to be the origin of the three axes, we can cut the sphere like this. That is, horizontally one cut and vertically two cuts. So if you cut, you will be having 8 pieces totally. That is top portion 1, 2, 3 and then backside one part. Okay, so 4 pieces. Similarly, bottom we are having 4 pieces where that center point is called the origin, and which is the origin of the three axes. So which means that here we can cut the sphere into 8 equal parts. So in that 8 equal parts, one part alone lies in the first octant where all the three axes are positive. Okay, so if we consider the volume of that particular region, that is in the first octant, we can finally multiply by 8. That will give you the volume of the whole sphere. So that what we are doing here is we have to consider the formula as 8 into triple integration. Okay. So this is equal to 8 times of triple integral dz dy dx. So that we can consider the volume for the first octant alone, then we can multiply by 8. It will give you volume of the whole sphere. So now we have to identify the limit for that first octant alone. Since we are considering the first octant, the lower limit will be 0 here. We have to find out the upper limit alone. So lower limit you can fix it to be 0 everywhere for all the three integral. While finding the upper limit first we have to find out for the innermost integral, that is with respect to the variable z. So that can be taken from the given equation of the sphere, that is x square plus y square plus z square equal to a square is the equation of the sphere, means we want z square is equal to what? So z square is equal to a square minus x square minus y square, right? So or otherwise z is equal to plus or minus root of a square minus x square minus y square. Since we are considering the first octant or the positive octant, we have to take only the positive value, so that we can write the limit of z as a square minus x square minus y square. So this is the limit for the variable z. Similarly, to calculate the limit for the variable y, for that variable y, already z we have calculated, so that we are left with y and x, which means that we are reducing the 3D into three-dimensional diagram into two-dimensional one, which means that this two dimension means sphere will be reduced as a circle. Okay, which gives you the equation x square plus y square is equal to a square which means that from this y square is equal to a square minus x square, so that y is equal to again plus or minus x square, sorry, a square minus x square. So again here, since we are considering the first octant part, the upper limit should be taken as positive alone, which will be a square minus x square, right? And finally we are left with the single variable x, where x varies from 0 to a, because this equation again reduces to x square is equal to a square, which means that x is equal to plus or minus a. From that we are taking the positive quantity a. So this is the way we have to identify the limit, which means that while calculating the limit for z, directly we can take z value from the given equation. Next, to find the limit for y, we have to consider z equal to 0. That is, we are reducing 3 dimension to 2 dimension by making z is equal to 0. If you put z equal to 0, the equation reduced to x square plus y square is equal to a square. From that we can find what is y. Similarly, again here to calculate the limit for x, we need to put z equal to 0 and y is equal to 0, so that we will be getting the limit for x as a. So likewise we have to find out the limits for x, y and z. So now this we have to integrate it. Now let us integrate this. Integral 0 to a, integral 0 to root of a square minus x square. So integration of dz is z over the limit is 0 to a square minus x square minus y square. So here it should be 8 into dy dx. So now this is equal to 8 times of double integral root of a square minus x square minus y square dy dx. So this we have to integrate with respect to y again. So for our convenient, what I am doing here is I am replacing capital A square by a square minus x square, so that this integration becomes 8 into double integral root of a square minus y square dy dx, so which will be easy for calculation. So 0 to a, this is 0 to root of a square minus x square. Since we have substituted a square minus x square as capital A square, so root of a square minus x square will be a. So we can substitute here as capital A as a limit. Now here we know the formula for root of a square minus x square dx formula. That formula is integral root of a square minus x square dx. This is a formula. This is equal to x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a. So this is a formula. We have to apply this formula here. So this is equal to 8 into integral 0 to a. Here it comes y by 2 into root of a square minus y square plus a square by 2 into sine inverse of y by capital A over the limit 0 to capital A and then dx. Now we have to apply the limit in place of y as a. If you put the limit y is equal to a here, a square minus capital A square will become 0. Similarly, for lower limit is 0. Here in place of y, if you put 0 here, 0 into anything 0. So for both upper limit as well as lower limit, the first term will become 0. Next, coming to the second term, if you put y is equal to a here, it becomes sine inverse of 1. What about the lower limit? Sine inverse of 0 is 0. So what do you have? Finally, you are having the value only for the upper limit alone for the second term. So now we can write it. Now substituting the limit, here we will be having a square by 2 into sine inverse of 1. Remaining all the terms are 0 into dx. But what is sine inverse of 1? This is pi by 2. So again, what is a square here? A square minus x square, right, by 2 into pi by 2 dx, right? So here 2 into 2 4, this is 8, so this is equal to integral 2 into or 2 pi into integral 0 to a square minus x square dx. So this we have to integrate with respect to x. So this is equal to 2 pi into now a square into x minus x cube by 3 over the limit 0 to a. So now while substituting the upper limit will be getting a, for lower limit it is 0. So while putting the upper limit a cube, here a square into a is a cube minus a cube. So we can take common 2 pi a cube into 1 minus 1 by 3. So this is equal to 3 minus 2 is, 3 minus 1 is 2. So 2 by 3, which means that final answer is 4 pi a cube by 3. So already you know that the volume of the sphere is 4 pi r cube by 3, where here r radius is nothing but a, so that we got the answer as 4 pi a cube by 3. So this is the way we have found out volume of the sphere using triple integration. In this video, let us see one more question. Find the volume of the tetrahedron bounded by the coordinate planes and 3x plus 4y plus 6z is equal to 12. That is another plane using triple integration. So tetrahedron means the diagram will be like this. Okay, this is the shape of tetrahedron, where it will consist of 4 sides. 4 sides means you can look at the diagram, that is bottom one side, okay, and then that is front part is one triangle, that is the equation of the plane 3x plus 4y plus 6z is equal to 12, and all the 3 coordinate planes. Actually bottom is one of the coordinate plane. Coordinate plane is nothing but here we have considered z-axis, x-axis and y-axis, so that zx is nothing but y is equal to 0, which is zx plane. Similarly xy is nothing but z equal to 0, it is called as xy plane. Similarly here zy plane, or otherwise we can say x is equal to 0. Okay, so which means that the whole portion of the tetrahedron itself lies only in the positive octant, right? So it is not like sphere. So whole portion of the tetrahedron is lying in the first octant. So here there is no necessity to multiply by 8. So here the volume formula is, directly we can consider triple integral dx dy dz, okay, to find the volume of the tetrahedron. Since everything lies in the first octant, obviously the lower limit will be 0 for all the 3 variables. Now our aim is to find out the upper limit. As usual, for the upper limit, to find out the variable x, here we have considered the order as dx dy dz, so we can start with x here. So to get the limit for the variable x, we can take what is x from the equation directly. So 3x plus 4y plus 6z is equal to 12 means here x is equal to, which is given here, x is equal to 12 minus 4y minus 6z divided by 3. Okay, so this will be the upper limit here. We can write 12 minus 4y minus 6z divided by 3. Now what about the limit for y? So as I said, this we have to consider or reduce it into two-dimensional diagram. So once we reduced into two-dimensional diagram, it will be in a form of a triangle. That is, here we can omit the z-axis and we can consider this xy plane alone. So xy axis alone. So this xy plane, if you see, this is a form of a triangle where this is the line given by the equation y is equal to 6 minus 3z by 2, which means that I told you that we have to consider x is equal to 0. If you put x is equal to 0 in this given equation, it will reduce to 4y plus 6z equal to 12. From this we want y, right? So y will become 12 minus 6z divided by 4, or otherwise we can write y is equal to, if we cancel throughout by 2, it gives you 6 minus 3z divided by 2. So this is what here given mentioned in the diagram. So that the upper limit for y will be 6 minus 3z divided by 2, right? And what about the limit for z? Again we have to put x equal to 0, y equal to 0 in the given equation, which gives you 6z equal to 12, that gives you z equal to 2. So we can consider the limit for z as 0 to 2. So this is the way we have to identify the limits for the three variables in case of tetrahedron. Now as usual, already you know the limits, as usual we have to integrate the triple integration. Now we have to integrate this. First, if we integrate with respect to x, here it will be like this. X, that is integration of dx is x over the limit is this. So here we can simplify this also. We can take 2 common. So that 2 by 3 will be taken outside. So that will be left with 6 minus 2y minus 3z into dy dz. Okay, after applying the limit for the innermost integral. Now we have to integrate with respect to y, right? Since we are going to integrate with respect to y, if we write this like this, it will be easy for simplification. I will show you. So 6 minus 3z we can write separately, and then we can write 2 minus y separately. Okay, then you integrate with respect to y. Okay, so this becomes 2 by 3 integral 0 to 2. So 6 minus 3z become constant when you integrate with respect to y. So this into y, first part, minus 2 into integration of y is y square by 2. So this is the integration of 2y, and then now you put the limit, upper limit minus lower limit, and then we are left with the derivative dz. So now we have to substitute this limit in place of y alone. Okay, so while putting it in place of y, integral 0 to 2, 6 minus 3z into y is 6 minus 3z by 2 is the upper limit, minus 2 we can cancel. So 6 minus 3z by 2 whole square. Okay, this is upper limit alone, lower limit 0, so both the term will become 0, and then we have to integrate this with respect to z. So by simplifying this, 6 minus 3z whole square is common in the numerator. So what we can do here is, we can write 6 minus 3z whole square as common term. So here we are left with 1 by 2, and then here denominator 2 square is 4. So 1 by 4 into dz, right? So now this can be written as, here if you take LCM here, 2 minus 1 is 1 by 2 minus 1 by 4 is 1 by 4. So 2 by 3 into 1 by 4 integral 0 to 2, 6 minus 3z whole square dz we have to integrate. So here we can cancel. So let it be 1 by 6 here, integral 0 to 2. Now we have to expand this. So a minus b whole square formula. So 36 minus, what is this? This is again 2ab. So again 36 into z plus 9z square, right? So this is dz. Now we shall integrate. So 1 by 6, here 36 into z minus 36 into z square by 2 plus 9 into z cube by 3 over the limit is 2, right? So now we can apply the limit here. So while applying the limit here, 1 by 6 into 36 into 2 is 36 into 2 is 72 minus, here again here 2 square means we can cancel this. So again here 36 into 2 will give you 72 minus 2 into z cube, 2 cube is 8. So 8 into 2 16. Sorry, this is 3. So 8 into 3 is 24. If you cancel 9 by 3, it becomes 3. So this and this get cancelled. So plus 24. So finally 24 by 6. The answer is 4 cubic units. So this is the volume of the given tetrahedron using triple integration.